So one of the things we like to do is look at new technologies, and there's a really cool technology that's coming out. It's a new type of wearable, but it's an in-eye wearable. Can you talk a little bit about what we're seeing in the market right now from these new soft contact lenses?
Well, seeing is the operative word. This is incredibly futuristic. So I think in terms of a game changer, this is probably one of the bigger game-changing technologies that's on the horizon right now. There's a couple companies that are looking at kind of the Oculus type of vision device, except this is done as a contact lens.
Okay, so instead of having to wear a big headset in front of you or even like a Google Glass style thing in front of you, this is literally like right next to your retina in your eye.
A contact lens that fits on the eye. So one company is called Mojo Vision.
Yep.
So they make a hard contact gas permeable lens. It's actually very big. It's called a scleral lens, and sclera is the white portion of your eye. So actually it's so big it actually sits on the white portion of your eye and leaves a bit of a gap.
Sounds comfortable.
It supposedly it actually is pretty comfortable because it actually has it's good for people apparently with dry eyes as well. Because you have to put a liquid in between it. So now I've tried gas permeables before hard contacts, and I've always had trouble with those. So to me the soft contacts are always much better. But I'll take them at their word. But so what they've done is designed a micro display that sits essentially in the eyeball portion. Extremely dense, so it's 14,000 pixels per inch, much more than you would see on any kind of a display.
What's that a display just for magnitude? Is it like 100 times more dense, 1,000 times more dense?
You would think of a couple of hundred pixels per inch as being in the upper limit. So this is far higher than that. And out of that, they get a display that's 250 by 250 pixels, monochrome, but it's basically floating in space then right in front of you. And they have all of the circuitry designed that is embedded in this gas permeable contact lens. Not only the technology to do the display, but also the power management to handle it, a radio communication device to contact the another device off of it to help supply contact, a biosafe battery. So that's all done on a lens basically.
That's incredible. So you have a system on a contact lens, and it has to have its own power capabilities. As you mentioned, it has radio capabilities, so it can communicate with a smart device. I'm assuming you'll be doing some of its hardcore processing up in the cloud over some kind of a 5G network or something like that, so that when it's displaying rich imagery or directions or whatever you want floating in front of your retina there, it'll be interesting information. I'm assuming that'll come from the cloud. So it seems like it will be relatively power intensive in order to drive the functionality. Do either of the companies that are promoting this right now give any direction on power consumption or longevity, how long these would last between recharges or between having to get a new lens?
I think they're talking about, certainly for Mojo Vision, they're talking about once a day wear, and there's a limited duty cycle that they can handle. Now, right now, this reminds me of the old days of computers, where in the early days back in the 70s or early 80s, you had fairly low resolution monochrome displays. It was just too power intensive to have more than that, and then over time kind of Moore's law took over, and all of a sudden you have these fantastic displays that happened over the years. I assume the same thing is happening here. I think they're limiting the amount of usage that they're able to do right now, or the intensity of the processing. Now the way they describe it is you're going to have one on each eye, and because the communication has to go to someplace, and it's got to be someplace close to limit the amount of power. They're talking about something like a neck brace, or not a neck brace, but
be a little extreme.
A necklace. That's going to help with the communication, and essentially, and I think it's like a 5 gigahertz communication, so it'll be similar to like a Bluetooth. But even from there, then that'll probably go to a smartphone or the cloud or another device to aid in the communication.
There you go. So like more of like there's a link in between. It's not just going from eye to cloud, at least in their early iterations. Okay. Well, someday it will probably get there, and it'll be pretty cool. What's an application that What do you think would be just like such a cool application of an in the eye display?
Well, what they're talking a lot about is, initially fitness equipment. Obviously, when you're working out, you can see your heart rate per minute and all these other metrics coming up.
Okay.
They're also talking about walking around at the airport as you're walking to your gate. It's kind of telling you where to go, where your seat
left,
assignment
turn
is,
right, yeah.
and all of that. I'm thinking back to my days in college where it would be nice on a test to basically, have all the notes right in front of me.
That'll
So-
create all new complexity for teachers.
Yeah, I think the use cases are almost endless here, probably more than most other technologies that you can see. I mean, I can really see where this is going to go forward. Now, another thing they're talking about is probably the first use case are for people that are visually impaired in some way, being able to aid them, which is really an incredible breakthrough.
Yeah, that's really cool. I remember we had some overlap with a organization called Second Sight, which was creating artificial retina implants for people with impaired vision. So there's a lot of need there, and if you can help people see better or see again, that's huge. So thanks for sharing this with us.
Sure.